Hello, Algebra 2. We're going to take a little trip down memory lane to review some factoring. Now, I absolutely love factoring. It's one of my favorite parts of algebra. So let's review some of these concepts. When you're factoring, you first want to look for your GCF, or your greatest common factor. That's your first step that you're going to look for. So if we're looking here at an example, we might have something like 15 x to the 5th, y to the 3rd, z plus 10 x to the 3rd, y to the 2nd, z minus 5 x squared, y, z squared. All right, so that greatest common factor is the same thing that you can pull out of every single one of these terms in the highest amount. We can notice here that we can pull a 5 out of all of our coefficients here. So we're going to say 5. And then the highest x that we can pull out is x squared. And we have a y and a z that's common for all of these. And then inside the parentheses, you write what you're left over with. This is like that distributed property backwards. So 3x to the 3rd, because x squared times x to the 3rd is x to the 5th, y squared, and z times 1, or z times itself, is just z, plus 2x y, and that's z, and one more minus, and for this one we're just going to have to, the x squared is already pulled out, the negative 5 is already pulled out, and then we're just multiplying this by 1z to get negative 5x squared y z squared, and we can close off those parentheses. So that's the first thing that you want to look for, is that GCF, right? Pull out your greatest common factor. Then after your GCF, the most common thing that we use is when we're factoring a trinomial. And that's something like ax squared plus bx plus c. I'm going to even put a little star next to this one because it's pretty much what we're working on right now. Right? We're working with these quadratics, so we have to be able to factor these trinomials. With example 2, we're going to do 3x squared minus 7x minus 6. And there's many ways and many methods that we use to go ahead and factor a trinomial, but basically it's figuring out the two linear binomials that when you multiply together, they get this trinomial. And there's something special about them, and that is that these first three terms multiply to 3x squared, and then these last two terms multiply to negative 6. So our job here is to figure out the combination of these middle terms. Now the method that I use is that I take the first coefficient times our constant, and I put that at the top of this little x, so I say negative 18, and then I put our middle coefficient at the bottom, negative 7, and we're figuring out the two numbers that multiply to negative 18 and add to negative 7. That's a negative 9 and a positive 2. And these are what we call my goal numbers, or the fact of this one is going to multiply to a negative 9x, and this one's going to multiply to a positive 2x. And so now I kind of have these goal numbers, and I can figure out from there what these combinations are. So I know that a 3x times x is going to get me 3x squared. But now I'm looking at this bottom one. So 3x times what's going to get me negative 9x. That's a negative 3. And I can follow along this rainbow. X times 2 is going to get me 2x. So I put a positive 2 there. And so my answer, if I just want to rewrite this over on the side, 3x plus 2 times x minus 3 is what this factors into. Let's try that again. We'll choose screen. So I'm going to have an example 3 with factoring these trinomials. 6x squared minus 13x minus 8. And once again, I know that these multiply into two linear binomials. I'm going to set up this little diamond over here on the side. And I know some of you use the box method. It's a kind of the same method. You just notice that I write mine on the little rainbows. So negative 48 is at the top. That's because 6 times negative 8. Negative 13 is in the bottom. From here, I can know that negative 16 times 3 is a negative 48, and that adds to negative 13. I'm going to write my goals down here. I know that this is negative 16x. This is a positive 3x. And from here, I kind of just play that factoring game. So I'm first looking at this 3x right here. And the possibilities of 3x that are going to work for me are going to be a 3x times a positive 1, because I know that last one needs to multiply to a negative 8, so that leaves us with a 2x. And just kind of checking that out, that definitely works. So my final answer for this one is 2x plus 1 times 3x minus 8. So those are the trinomials. Those are the big ones. Then let's move a little bit into these special cases. So these special cases are things like a difference of squares. And difference of squares looks like a squared minus b squared, and it factors into a minus b times a plus b. So our first example for this one, so example 4, would be 49x squared minus 81. And what's special about these is that they're two terms connected by a minus sign, and both of them have a perfect square, meaning that 7x squared gets you 49x squared, and 9 squared gets you 81. So if we're factoring this, it's going to be 7x minus 9 times 7x plus 9. And you don't have to write the plus or the minus in certain ones. It just has to be, one has to be plus and one has to be minus. Let's try that one more time with a different one. We can write it over here on the side so we don't waste room. Example 5. We're going to have 32x squared minus 50. And the reason that I'm pulling this one is that we first need to look for that GCF. So there's just a little bit of an extra step in this. It's 2. So 16x squared minus 25. And now we see that we have a difference of squares. We know that 4 squared is going to use 16x squared minus 5 times 4x plus 5. So a reminder that you want to look for that GCF first. All right, our other special case, jump back to purple here. Our other special case is what we call a PST, or a perfect square trinomial. And they either look like a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And this is what happens when you take a binomial and you square it. So example 6 here would be something like 121x squared minus 66x plus 9. So this is a trinomial, and we definitely don't want to set up a diamond because 121 times 9 is a big number. We don't want to worry about that. But we do notice that 11x squared gets you 121x squared, and 3 squared gets you 9. So we're just going to do a little bit of a check here, and for sure we have 2 times 11x times 3 is going to get you that 66x squared. We just have to watch our sign here. All right, so when you're factoring these, you take the first term, which is, the square of the first term, 11x, right? And then we're going to say plus, minus, because you take the sign in the middle, so 11x minus 3, and you're going to take 11x minus 3, which rewrite as 11x minus 3 squared. And it's just taking those two perfect squares and writing them together. We're going to have to come back to this a little bit after ski week, so please make a note of it. Let's try one more example and make sure that we can get that down. Example 7. So 4x squared. And this one's a plus, so plus 28x and plus 49. I hope you can see here that we have a 2x squared. And this is 7 squared. And this one in the middle is 2 times 2x times 7. So this factors into 2x plus 7 squared. And that plus comes from the fact that this sign is a positive. So those are the reviews of factoring. I want us to try a few examples together, just in general. I know there's a lot of examples on this one, but factoring is important. So example 8, we're going to try 6x cubed minus 24x squared plus 24x. So first step is to look for your GCF. Feel free to pause this video and try it on your own, then play. So 6x is my GCF from here, leaving me with x squared minus 4x plus 4. Ooh, speaking of those perfect square trinomials, that absolutely is a perfect square. So this is 6x times x minus 2 squared. And I can't factor that anymore, so that right there is my final answer. Oh, I don't like that, but the box it like this so you can see. That's my final answer. All right, let's jump to pink. Example 9, negative 6x squared minus 10x plus 4. And I'm going to actually star this one because this looks like what we've been using. So it looks like quadratic, or I'm going to say standard form. So this looks like standard form, right? That's what we've been working with. And we want to go from standard form to root form. And how we do that is that we factor. So we're going to factor out a negative 2, x squared plus 5x. I left out a 3. 3x squared, there we go, minus 5x, and this is plus 5x minus 2. There we go. That looks a lot better with it. Thanks for staying with me. Okay, and then we're trying to set up that diamond. So if you wanted to set this diamond up over on the side, it's a negative 6 and a 5. So those two things are a positive 6 and a negative 1. So when we factor this out, it factors into 3x, because I know 3x times x is going to give me that 3x squared. And then my last terms are a negative 1 and a positive 2. So that's not quite factored form. You'd still have to factor out a little bit more, but at least it starts to show you, I'm going to say it shows roots, because you're going to end up solving for your roots there, which is pretty cool when we go to our from standard to root form. We're on the right track for that one. Last one, I definitely promise. I'll put it in green, which is one of my favorites. Last one, example 10. You guys have been troopers tonight. You've stuck through it. So the thing about this one's an official Algebra 2 1. It's an official Algebra 2 factoring one, and this looks a little bit different. So we have 81x to the 4th minus 1. This is a difference of squares, and I know that it's going to be 9x squared plus 1 and 9x squared minus 1. And that's because 9x squared times 9x squared gets you 81x to the fourth. And 1 times 1 gets you 1. Now here's the thing about it, is that you can't just stop here. You have to notice that 9x squared minus 1 is another difference of squares. So factor completely. Make sure that you keep going. Don't just stop after you factor it once. So we're going to drop this part down here. 9x squared plus 1 times 3x plus 1 times 3x minus 1. And now you are factored completely. You have totally finished this problem. Excellent job. I will see you tomorrow.